Hello everyone, my name is Mayur Chawda. Welcome to my YouTube channel. Today I am going to explain assignment 3 neural networks for subject Introduction to Data Analysis. Key stat for the assignment. So to get the key stat, we are going to Jupyter Notebook to get the codes. So first step is to load the libraries. So we are importing pandas and numpy and matplotlib for plotting the plot. So for pandas, import pandas as pd, import numpy as np, and import matplotlib.pyplot as plt to draw the plot. Now, second step is to load the data in our dataset. So we have given the datasets as liu data to our dataset name. We have CSV file, so we are using .read CSV command to get the file. So our file name is liuanalysis new.csv, liudata.head function to print out the data. So total 6 variable we are having in the file: cell, smear, infill, li, blast, temperature, and remis. Out of that, cell, smear, infill, li, blast are independent variable and temperature is dependent variable. Now to show the key statistic, we are using dot describe function from pandas. So key stats is equal to liu data dot describe function. So we'll get all the key statistics. Insights from the dataset. So for cell is cellularity of the marrow clot section. The average value of the cell is 0.88, whereas the standard deviation is 0.1866. The minimum value of cell is 0.2 and the maximum value is 1. For smear differential percentage of the blast. The mean of the smear is 0.6351 and the standard deviation is 0.214. The minimum value in it is 0.32 and the maximum is 0.97. For infill, the percentage of absolute marrow leukemia cell infiltrate. The average value of infill is 0.57 and the minimum value is 0.08. The 50% values of infill is 63, meaning half the data values are below 0.63. Labeling index, percentage labeling index of the bone marrow leukemia cells. The standard deviation and mean of labeling index are 0.4678 and 1.0037 respectively. Minimum and maximum values are 0.0 0.4 and 1.9 respectively. Blast. The absolute number of blasts in the peripheral blood. From the given dataset, we can say that when there is no blast, it is minimum value and the maximum is 2.06. The average value of blast is 0.6885 and the standard deviation is 0.53496. Temp. Highest temperature prior to the start of treatment. The average temperature is 0.9974 and the standard deviation is 0.01483. Minimum and maximum values are 0.98 and 1.04 respectively. Now we'll get the classification report. So we are explaining 3 variables for classification report: precision, recall, and F1. To get the classification report, we'll go to Jupyter Notebook to understand the coding part. First, we'll assign X and Y variable and then create the code for train and test data set. So for X axis, we'll be dropping a remis column from our data set and we'll assigning all the data sets apart from remis column as X column, and for Y, we are taking remis as column. So create X and train and text data set. So test data size as 20% and 80% for training. Now use the scaled data using standard scalar function and assign train and train set 2. Now for net algorithm, we are using neural network algorithm. So from sklearn.neural.com import MLP classifier. So for MLP classifier, we are using 3 variables. So hidden layer sizes are 642, max iteration will be 10,000, and our random state is equal to 100. So for evaluation metrics and report, we are using sklearn.metrics, import classification report and confusion metrics. So we'll get precision, recall, F1 score and support. So precision, how many are correctly classified among the class is called the precision. So class 0 has higher precision than class 1, which is about 25%. The macro average of precision is 0.50 and the weightage average is 0.56. Recall, how many numbers do you find over the whole numbers of element of this class? The macro average and weightage average of recall are 0.62 and 0.67 respectively. F1 score. So F1 score is between harmonic mean between precision and recall. The macro average and weighted average of F1 score are 0.62 and 0.67 respectively. The accuracy of the F1 score is 0.67. Now, the comparison of classification report between neural network and logistic regression. As we can see, the precision difference in the classification using logistic regression is 34%, but after classifying the dataset by using a neural network, the algorithm, it decreases to 25%. This means that only 25% of the dataset is correctly classified among the class. Similarly, recall and F1 score have same values for class 0 and class 1 as precision. The key point, by using the neural network algorithm, we can get some macro average values for precision, recall, and F1 score. Likewise, using neural network algorithm, we can get some weighted values of the precision, recall, F1 score. The accuracy of the classification using a logistic regression algorithm is 50%, whereas it is 67% using neural network algorithm. Now the last point, performance improvement for neural networks. So we are assigning three ways to improve the performance. First one is check for overfitting. Data is tested to check if it's not overfitted. Data can be fitted in 3 ways: underfitted, good fitted, and overfitted. Data must be robust for getting high classification accuracy. Visualizing the data also helps to find whether the data is overfitted or not. If the data is overfitted, it leads to an error in the test set. So it should be always not be overfitted and not be underfitted. Second point is hyperparameter tuning. So each neural network has its own base set of hyperparameter which leads to maximum accuracy. But we can't say there is no specific way to identify the best hyperparameters of the model. Only we can apply the trial and error method. So by trial and error, we'll find the best hyperparameter. So increase the maximum accuracy. Last one is assemble the algorithm. After trying all the best ways, if one is not getting the accurate neural network model, one can create an ensemble, which means the replica of neural network combining the predictive power. One can also use differential neural network architecture. It's not necessary to follow any architecture and training them on different parts of data and ensemble them for getting the high accuracy of the model. The best thing for improvement, it is the trial and error method on different parts of the area. Thank you.